Okay, so for our last day of the unit, so we did skip 2 of the days. So on those days, they were just types of trig identities and equations. They're not necessary, and normally if you were going to have to use them, they would be given to you and you would just use them in a problem. So that's why we kind of just skip those 2 days. If you're taking calculus next year, you are not missing anything that you will have to know for calculus. So for day 6, we are solving trig equations, like we also did in Unit 5, but these are a little more complicated. So looking at the top, kind of the steps we're going to go through. So it says use identities to make sure all angles are the same. So we're going to have some that have a theta as the angle, and some are going to have like 3 theta. In order to factor and solve, they all have to have the same theta value or x value. You can't have one with 3x and one with x. So then it says if all angles are the same but they have multiple angles, we have to adjust the domain. So when we are working with like the 2x, we're going to have to really do what I call 2 rounds of answers, because 2x would mean that you have the unit circle, and you would need to complete the whole unit circle, but you will be changing your domain to be a little bit broader. So we'll look at that with the problems. We're going to use some of our identities that we learned the other days to minimize the number of trig functions that we have before we can solve. We always want to rearrange and get it set equal to 0 and then factor. In some cases you might have to square both sides if you can't factor it, and then we just need to make sure if we have denominators that we check our answers. Okay. So taking a look at number 1, so we want to solve on the interval from 0 to 2 pi. So think about the unit circle. We have to get all the answers that would be in one round of the unit circle. So 2 cosine squared x minus 5 cosine x equals negative 2. So because these are both cosine here, so we have the same trig function, so we're good. And because they both just have a regular x here, we're good. So there's nothing we have to change. So we're ready to factor. We just need to move over that negative 2. Make sure this is in the correct order. Okay, so we have to do the long factoring because we have this 2 out front. So 2 times 2 will give us 4. Finding 2 numbers that multiply to give you 4 and add to negative 5. So negative 4 and negative 1. So if we bring down our first term, and then we're going to replace the middle terms with negative 4 cosine x and minus 1 cosine x. And we're going to bring down our 2. So then we're going to use grouping. So the GCF here is 2 cosine x. So we'll have cosine x minus 2 left. And then the GCF here, we just want to take out a negative 1. And that'll leave us with cosine x minus 2. So my insides are the same. So one factor is cosine x minus 2. Other factor comes from the outside part, so 2 cosine x minus 1. So if we split those up, so we're now ready to solve because these are equal to 0. So on the left-hand side, we have cosine x minus 2 equals 0. So this is cosine x equals 2. Okay, so thinking about your unit circle, and let me bring your unit circle up. Just a second. So if you think about on the unit circle while I'm bringing this unit circle up, is there anywhere on the unit circle where cosine or the x value is equal to 2, or really any number that is bigger than 1? So here's the unit circle for us to take a look at. So is there any place where cosine x value or y value really that's equal to 2? There's not. So that just means that that answer right there is out of our domain, so this will not give us an answer. So we can mark that out. Okay, doesn't mean we're finished, so we're going to look at the right side. This will be 2 cosine x minus 1 equals 0. So we're going to have 2 cosine x equals 1. So cosine x equals 1/2. So we're looking anywhere on the unit circle when our cosine or x value is positive 1/2. So one place is at pi over 3. And then the other place where the x value is positive 1/2 is down here at 5 pi over 3. Okay, and just to kind of reiterate about that domain that they mentioned, the domain here was just from 0 to 2 pi. We looked on the unit circle. We didn't have to do anything special here just because these were regular x values, and there's not a number with that x, which we'll see in a little bit. Alright, so moving on to the second one. Okay, so for your second problem, we have this tangent sine x. There's really two here. So 2 tangent x sine x plus 2 sine x equals tangent x plus 1. And it does give you a hint that says to factor by grouping. So we will factor by grouping, but before you can factor, we do have to make sure that everything is on the same side. Okay, so let's move everything over to the left-hand side. Okay, so everything's on the same side. So we're going to group, which is what our hint said to do. So the GCF from the first two would be 2 sine x, which would leave us with tangent x plus 1. And then the GCF for the second two would be negative 1, which will leave us with tangent x plus 1. So the insides are the same. So one factor is tangent x plus 1. And the other factor is the outside part, 2 sine x minus 1. And we know that's equal to 0. Okay, so we're going to split these up. Alright, so on the left-hand side, I'm going to have tangent x equals negative 1. Okay, so taking a look at your unit circle, we're trying to find when y divided by x, because that's tangent, is negative 1. So remember, to get 1 or negative 1, you're looking at the ones that have square root of 2 over 2. So at 3 pi over 4, that would give us negative 1 for tangents. And then the other place that this would occur would be over here at 7 pi over 4. Okay, and then for the right-hand side, if we set it equal to 0, so we're going to be looking for when sine, or the y value, equals positive 1/2. So if you look over here at pi over 6, that happens. And so looking for a positive y that's 1/2, that also happens at 5 pi over 6. So we have 4 answers this time. This problem also was just a regular domain. We didn't have to do anything to fix it. It was still just looking at one round of the unit circle. So we had our domain like that. Alright. So next, for problem 3, we're looking at the 4 cosine squared of 2x minus 3. Okay, so here's where things are a little bit different. So because there's really nothing that you can, like there's only one trig function, so you're not going to change trig functions. But because we have this 2x and not just the normal x, we're going to have to fix the domain, okay? So for a normal problem with just x, so if it would have just had an x there, domain would have been from 0 to 2 pi. That's what the problem tells us. But because we're doubling this and we have 2x, that means our domain is technically from 0 to 4 pi. Okay? So what that means is, whenever you're doing this problem, if you see a 2x, okay, because there's that 2 there, we're going to do 2 rounds of answers. And whenever we get to the part where we have to do our second round, you're always going to add 2 pi over whatever the number is with x, so we're going to be adding 2 pi over that 2. Okay? So this will come in handy when we get to the end part of the problem. Okay, so solving this problem, there's no factoring to do, so we just want to get cosine squared by itself. So add over to 3, and then I'm going to divide by that 4. Alright, to get rid of the square, we want to take the square root. When you take the square root, you have to include the plus or minus. Okay, the square root and the square cancel here, so you're left with cosine of 2x equals, we still have our plus or minus, square root of 3, we're just going to leave as square root of 3, but square root of 4 is 2. Okay, so it says cosine of 2x, this 2 is inside of cosine, so you cannot just divide by 2, is equal to plus or minus the square root of 3 over 2. So once again, we have this 2x, which means we're going to have to do 2 rounds of answers. So for the first round of answers, you're going to use your unit circle, and we want to look at all the places where cosine, or the x value, is square root of 3 over 2. Okay, so first, and it can be positive or negative, so we're looking at that. So the first place where it's positive, square root of 3 over 2, is at pi over 6. Now, normally we say x equals, but because this was a 2x, we're going to say 2x equals pi over 6. Okay, and I'll come back to those in a second. So other places where we have square root of 3 over 2 in the x value, so we have one at 5 pi over 6, so we're going to do the same thing. 2x equals 5 pi over 6. And then next place is at 7 pi over 6. Remember, these should all have the same denominators when you're getting your answers. And then square root of 3 over 2, the last place that happens is at 11 pi over 6. Okay, so we need to solve this for x because we don't want it to be 2x. So if we solve for x, you're really going to divide each side by 2. When you divide by 2, it really just multiplies with the denominator you already have. So this is going to be pi over 12, so that's one of your answers. Alright, so if we divide by 2 here, it would be 5 pi over 12. If we divide by 2 over here, it'll be 7 pi over 12. And divide by 2 here, it'll be 11 pi over 12. Okay, so before we do our second round of answer, I want you to think about why we're doing the second round of answers. So, if you were to figure this is like 1/12, 5/12, 7/12, and 11/12, if you just kind of ignore the pi. If you look at 11/12, 11/12 is close to 1. Remember, the whole unit circle goes around to 2 pi, not just 1 pi. So when we are getting our answers, we really only have the top part of the unit circle here. So the reason we're going to have to do another round of answers, 2 rounds, is so we can take care of the entire unit circle here and we're not leaving out things that we missed. Okay? So whenever you have a 2x here, this 2 tells you this is your first round of answers, you're going to have a second round. When we see a 3 here later, we're going to have 3 rounds of answers. It could be 4 rounds of answers. Don't normally get more than that, but that's what that means. So 2 rounds of answers. Up here we already kind of wrote some information. So we're doing 2 rounds of answers. We already have 1. We're adding 2 pi over 2. The 2 came from because it was 2x. Okay, so to get our next round, we're going to add 2 pi over 2 to each answer. Okay, 2 pi over 2 is pi, so if you want to just think about pi, that's fine, or you can do 2 pi over 2, it doesn't matter. So I'm going to take my first answer here, which is pi over 12, and we're just going to see how it works out. So if I do pi over 12 plus 2 pi over 2, now those are going to have the same denominators. So if I change this to have a denominator of 12, this would have to turn into 12 pi up here. Okay, so pretty much I'm going to be adding 12 pi over 12 to each one. That way it'll help because they all have the same denominator. So my next answer is going to be 13 pi over 12. Move this up a little bit. Okay. So there's another answer. So then if I take my 5 pi over 12 and add my 12 pi over 12. My next answer is going to be 17